Computers store memory by spinning a stack of magnetic coated plates beneath an electromagnetic head. Suppose a head consisting of a 148 turn coil. So the number of turns is 148 turns. Wrapped around an iron ring with an area. The area of the ring is 1.25 times 10 to the power of negative 8 squared meters. The head is parallel to a magnetic field. Let's assume that this is the head. So if it's parallel to the magnetic field, we'll assume that this is the magnetic field. Then the angle between the normal to the head and the magnetic field is 0. So theta is equal to 0 degrees. That changes by, so the magnetic field changes by 5.2 times 10 to the power of negative 4 Tesla. Delta indicates the variation or a change in. This change happens in a time duration of 8.5 times 10 to the power of negative 9 seconds. What is the induced electromotive force? So we have to find the induced electromotive force in the coil. The formula for the induced electromotive force is EMF equals minus N delta flux by delta T. N is the number of turns is constant. Delta flux means the change in the magnetic flux. So EMF equals minus N. The magnetic flux will be replaced by its formula BA cosine theta over delta T. Now, again, EMF equals minus N. I will take all the factors that do not change out of the variation factor delta, and I will keep the factor that changes, so that A is constant and the angle is constant. It becomes minus NA cosine theta delta B, which is the factor that was changing, by delta T. Now we replace EMF is equal to minus 148 1.25 times 10 to the power of negative 8, this is the area, cosine of 0, delta B, which is 5.2 times 10 to the power of negative 4, over delta T, which is 8.5 times 10 to the power of negative 9. So the answer for the EMF induced will be 0.0